Hi, I'm Malachi Sun, part of Team Golden Bears, and we addressed Honda's challenge. Our interpretation of Honda's design challenge was to create an innovation to improve accessibility and simplify the navigation of complex indoor spaces. Our solution is Thesis, a web-based application for conquering the labyrinth-like buildings of our world. Let's see a video of Thesis in action. First, we choose a building to traverse through. We pick a starting location, which is a location that is within eyeshot, and a destination. Currently, the path is displayed as text, but in the future, it would be displayed as a series of photos for each landmark and feature that is within an eyeshot of each other, so that the user would simply walk towards the next landmark or feature. So, how does it work? The key concept to our code is discrete graphs. An example is shown. Each vertex is represented by a node on the graph, and each edge is represented by a line between the two numbers. We can represent landmarks and features of a building as vertices of a graph. Landmarks may include statues, prominent art pieces, or anything else that is easily visible and pretty much static. Features are likely destinations, but could potentially change. A room number for a certain professor may be a feature, but a professor's room could potentially change if they hold office hours in a different location. Other features may include things such as bathrooms, water fountains, trash cans, and so on. After making all the vertices, we draw an edge between any two vertices if one is physically visible from the other. Now that we have a representation of our graph, we can simply use it. We employ an algorithm for finding paths through a graph. As of now, our code asks the user for what building they're in, a landmark that is close to where they currently are, and another feature for the target destination. This is inputted into the website, which is then integrated with our backend using Flask. Backend then employs an algorithm for finding the shortest path between the start and end location, and this path is then displayed to the user, currently as text, but in the future as photos. Improvability. The biggest advantage of using our graph-based approach is the fluidity, customization, and ease of improvement of the system. Did the escalator in the shopping mall break? Simply remove the vertex from the graph. If an area is cordoned off for an event, blocking a certain edge, this can easily be changed within our paths, or within our graph. Again, iterative and dynamic improvement and customization is where our solution really shines. Some great ideas for improvement including estimated time travel for each edge, which would allow a total path traversal time to be displayed for going through a building. We could also include whether certain paths are wheelchair accessible, which would allow the pathfinding algorithm to modify a path to have an alternative version which only considers wheelchair accessible edges. We could put RFID chips at landmarks physically in the building, which would allow the web app to produce audio cues when the user is facing a direction where they need to travel, which would allow Thesis to make traversing through buildings easier for the visually impaired. Certain edges may also be unsafe to traverse at night, which could, again, be another thing that would allow our paths to be modified. Thesis is a highly customizable graph-based web app that is very simple and easy to add functionality to. It can make spaces more accessible to the visually impaired and wheelchair-bound. Golden Bears would like to thank our sponsors, as well as the mentors and judges that made this opportunity possible. Thank you.